So,
Hi.
hello. So actually, I'm going to start today with just a little bit of a history lesson. All right. So how much do you guys know about the Russian royal family? Anything at all?
No. About Putin?
Okay. Not the Russian royal.
Putin?
It's understandable. Putin's not a king. He's the president. That's another story. We're not covering that here. So yeah, the Russian royal family, kings and queens, that kind of stuff. Do you guys know anything at all? It's fine if you don't.
No. I thought Putin was.
I heard about this, but then I didn't pay much attention about it, so I forgot most of it.
Fair enough. I mean, it's honestly not too interesting, but have you guys heard of the song Rasputin at least? Rah, rah, Rasputin, lover of the Russian queen. There was a cat there. That song. You guys have all heard of it, right?
No. What is that?
What? That's illegal.
Okay, you're not cultured, but that's also fine.
Literally illegal.
So basically, what happened in this time period was the Russian royal family. Now, first of all, how's the crown passed down from a king to the next generation? Just shout it out. Don't need to raise hands.
When somebody dies.
Loretta, say it again.
When somebody dies?
Yep. When they died, they have to pass the crown on. But how? Who is the crown passed to?
They pass it to the next heir that is bloodly related.
Exactly. And okay.
It's the oldest one. The oldest.
Again, a reminder. This is history, so it gets a bit sexist at times. Who is the only?
Usually to the king, next king.
So, yeah, to the next male child, right? So
oldest male child.
You're right, oldest male child. So in this time period, if they don't
have any, they go to the cousins.
Yes, I'm actually going to cover that later. So what happened this time period was the Russian royal family in the early 1900s, 1910s, they only had one male son, but this male son had a really, really serious blood condition called hemophilia. Do any of you guys know what that is? It's fine. So hemophilia is when in your blood, there's red blood cells, white blood cells, and platelets. That's mostly what's inside your blood. Now, do you guys know what platelets are? Do you guys know what all of that stuff does? All the blood cells, the platelets, all of that. Go ahead, Ethan.
I don't exactly remember what platelets are, but I'm pretty red blood cells are basically what makes your blood red.
Mm-hmm. Yeah.
And darker and lighter is because of oxygen.
Yeah.
The white blood cells are basically the things that attack things that your body doesn't recognize.
Yeah. That's perfectly correct.
Even if it's something good, they'll attack it anyways because they don't recognize it.
If it's not local to your body, white blood cells and the rest of your immune system will attack it. That's correct. Platelets specifically, they help clot your blood. So if you cut yourself, that's what the platelets go do. The platelets go and they block the cut so that you don't bleed to death. Problem with hemophilia is when you get hemophilia, you bleed to death even with the smallest cuts. If you get a paper cut, it's deep enough to hit a few veins, you can bleed to death just from a paper cut. So again, this was a very serious condition. And this wasn't the only condition that this child had. This child had also had all sorts of other problems. He had epilepsy. Go ahead.
So did he inherit this?
We're going to get to that. And you're going to figure that out yourself. You're going to figure part of that out yourself. So he also had epilepsy because, like Ethan said, all of these royals, sometimes they had to marry their cousins because as a royal, you could only marry someone who had royal blood. So they married their cousins. And the problem with, can you guys guess what is scientifically wrong with having children with your own family, with close family? Can you guys guess what's wrong with that scientifically?
First of all, it's just messed up in general.
Scientifically, we don't need to talk about morally.
second
Morally,
of
we know
all,
it's wrong.
It's like, because if your family has, let's say, a disease, and since they're closely related, it's weird if they both have that disease, but like they don't have it apparently. Their children can have a lot of diseases that their family carries, but they don't carry themselves.
That they don't express, right?
Yeah, they
That's
don't carry themselves, but like
yeah.
they don't show it themselves, but they have the alleles for it.
That's basically it. That's what happened to this kid, right? Because when you have just any family at all, inevitably, Loretto, do you have a question?
What's the kid's name?
The kid, Alexei. Alexei, the royal family's last name was the Romanovs. The son's name was Alexei or Alexis. It kind of depends on how you translate it from the Russian, I suppose. So what happened here was this kid, he had epilepsy. And this was in the 1910s, 1900s, when people didn't really understand how mental illness, all of this stuff worked. So being epileptic, there was no treatment whatsoever for it. The only person that could help this kid was an old man called Rasputin. Anyone heard of this guy at all? That's fine. So Rasputin, basically, he's literally a mad guy from the mountains, right? He's this guy who lived his whole life as a peasant in the mountains. He somehow ends up because he was a mystic, basically. He has high positions inside a church. He was a priest of some sort. So somehow he ended up in Moscow and ended up in the queen's court. Now, and whenever Alexei would have epileptic, go on.
Why is it Queen's Court, not King's Court?
It's basically the same thing, just the royal family's court. I was just referring to it as a whole thing. So again, that's what ended up happening. This man Rasputin ended up in the court of the king and ended up with, and he was the only person that could calm down Alexei when he started having these attacks. And due to this, he started getting more and more and more power, right? Because this is the only son, the only person that the Russian crown can be passed down to. So this guy gets more and more power. People start growing jealous. People start growing concerned. Some crazy guy from the mountains comes down from the mountains, and he's starting to influence the royal family. Some say he had a relationship with the queen. That's all been speculated. So then in the end, Rasputin got killed because he was simply too powerful. Now that itself was a story because Rasputin just wouldn't die for some reason. So these Russian noblemen invited him into his house. First, they gave him poisoned food. He ate it and he ate it. He had no problem whatsoever. He asked for more. They just straight up shot him 6 times because revolvers back then had 6 shots, right? They shot him 6 times. He crawled back up. Finally, they tried to dump his corpse into a river, and then that's how he finally died. But when he went back to where he dumped the corpses, they found that the ice under that formed over his corpse had nail scratches on them. So it's very possible that when they threw him into the water with bullet holes through him, he still survived. That's just a quick little history lesson, but for this class, we're going to focus a bit more on Alexei. So you guys definitely know what a family tree is, right?
Yeah.
I know you guys know, but just tell me, what do you guys know about it so far?
Like a tree that
Okay, one at a time first. Why don't we let Camille talk since she's been a bit quiet today?
She's frozen.
Yeah.
That appears to be true as well. I suppose, Loretta, then you take the floor.
A family tree is like, it's kind of like a tree, and how a tree grows more leaves from one, like kind of like that. It's like one person gives like has like a related a birth person like that, and then they add like a line to the tree, and they write their names, and then that list keeps going, and like they just keep, yeah.
Yep, that's basically it. So can you guys see? Can you guys see the file I sent? Like, can you guys access it?
What?
The file I put into the
You
chat.
sent it directly to me. You put a direct message. You need to change it to like it says it's like a little arrow thing that kind of looks like this, and then it says
yeah,
a name.
I did send it
press
direct.
everybody.
Yeah, that's my bad. I sent a direct message. Sorry about that.
That's the check mark.
Can you guys access the file though? Because I'm not sure if it's been acting.
No, I can't. It's not blue.
Like
Okay.
you probably typed it in wrong or something. You need to paste it. Like, that's
How
it.
about
Copy
this?
and paste.
How about this? Does this work?
Yes.
Okay.
Hemophilia, the royal disease.
What? I don't see it.
It's in the general
royal
chat.
disease thingy whatsoever. Can I see? No. Sorry.
Okay, so let me see if I can put you into breakout. It's been a while. Refresh my memory. How do I put you guys into breakout rooms again?
Right? I think at the bottom when you're the host, there's like a breakout room thing, and then you press the breakout rooms.
Okay, give me a sec.
It's at the bottom. I think it's next to reactions or somewhere. It's at the bottom.
Yeah.
And then it says like create breakout rooms or something. And then just invite people to breakout rooms.
Yeah. I don't think I've done this before. This is
Oh.
Basically, what you do is you just go to participants, and then you like press the person's name.
Okay, it's been a while since I used this. Whatever, we can do this together. That's fine. So you guys all have a copy of it, and I'll just share screen then.
Yeah.
So
It says Spanish royalty and English royalty.
So you guys can all see this, right? So give this tree a good look. Okay, first of all, I should teach you how to read this. If it's squares are male, circles are female. If they're black, they have hemophilia. If they're just normal, if they're not colored, they don't have hemophilia. So just, give it a look over the questions. Feel free to ask me if you don't know how to do them.
Really?
So have you guys all had?
Wait, does hemophilia not occur in females?
That's for you to figure out.
Because none of the circles are filled in.
I know.
Correct. So okay, that's the answer for the first question. If all of the affected people are male, what does this tell you about this disease?
Only for and female won't get it.
It's a male
Are you
disease.
sure?
I don't know.
It's mostly dominant in males.
Exactly. And what's the difference?
It's in X
what are guys-
chromosome disease.
Top of the class as always, Ethan. Okay. So that's your answer for the first question, basically.
Yeah.
Okay, Ethan, you said it, but I don't know if everyone else heard. What do you guys think? What do you guys think this is? How is this disease inherited?
Put that one perfect. V shapes. From what? From this paper and then pulled it out.
Lyndon, focus. Come on.
Well, my brother was talking to me. You have to blame him.
He can take this class too if he wants. So
move out of the way if you don't want to.
So again, this is inherited. How is it inherited again?
Is it dominant over the other one?
It's actually recessive. Okay, I shouldn't have told you that. I should not have told you that.
What?
Okay.
It's recessive?
It might be. I'm not confirming that. How is it inherited? Look at it carefully. Only the males seem to have it.
Yeah.
Right? Only the males seem to have it. But
give them a hint.
Are you sure that the females don't have it at all? That's a big enough hint. Come on.
I think they do have it because there's a person there, and it's a girl named Ish, I guess.
Give them a hint.
Pardon?
Can I give them a hint?
Go ahead. It's their fault for not listening anyway. Go on.
It's not my fault.
I'll just say.
Not my fault. There's people talking around me.
Yeah, same with me.
And the boys' chromosomes are XY. That's all I'm gonna say.
So the Y doesn't matter, right? Because X is more.
Just what did I teach you guys last time, right? Come on.
Y is nothing, right?
Y is nothing, and because Y is nothing, how does that make X very, very important?
Because it's double.
Because it's the only one there.
Exactly, and if it's the only one there, if it happens, come on.
Oh, if it happens once, it might happen again because it's only one thing. Did you have to tell someone?
I didn't hear because there was background noise. Well, kind of.
Can I just tell them?
Someone had background noise.
Can I just tell them?
Okay, fine. Just tell them then.
Basically, since the boys have a lack of another X chromosome, they have only one chance when they have X chromosome diseases, while the girls have two. So it's easier for the girls to fight over them, but the boys don't.
Right. So if it's
lack the second one here.
Right. So if this is X-linked, but if the girls have another healthy X, they don't have the sickness. So what does that tell you about this?
That the sickness is only in the first letter?
Not necessarily. Not necessarily.
An X chromosome disease.
Yep, it's an X chromosome disease. But remember, girls, if they have an affected one and a non-affected one, they can still they don't have the disease. So what does that tell you about it?
It's recessive and it's an X chromosome disease.
Exactly. That's the first question right there. So the second question then, we've already basically answered it. So yeah, look at the family tree. Who do you think the first person in it to have hemophilia was? Better question would be, who's the first person that we can prove had hemophilia?
Leopold.
Right. But look at Alexis or Alexei, whatever we want to call him. Right? He's not related to Leopold at all.
Who's Leopold?
He's just a king of.
No, but technically he's related because it goes up a bit.
It goes up, right? But think, who's the first person to have it? Oh. Remember, just because they're right. Just because.
I have a question. Why is there two Leopolds that have the same thing? There's two Leopolds.
They're unlucky. That's the only way you can.
These two are married, and then they have these many children, which is a lot. This is the first connection of this child right here, which does lead to this one, but we don't talk about that. since this is a girl, you can this can go through any of these girls and it won't affect them. But I can't see here. This girl right here, whoever's drawing triggers me. Their children, since it's a girl, it's okay. Since there's only one male, he's the only one, and he's probably gonna have it, which is the case.
Look, here's the thing. Who's the first person we can prove that had hemophilia? Come on, focus on that a little. Look at it.
Guy.
No, he's not the first person. He's not the first person, right? The first person we can prove had hemophilia. If he was the only one who had it, how do these guys all have it?
Like the first person we could prove it who has hemophilia is the Alexei or who? Because you told us.
It's Albert.
Are you sure it's Albert?
Or
because there's a bunch of people who didn't.
It's one of these.
Come on, Ethan. Albert's not affected. And remember, Albert's not affected.
And that person who born those two guys or whatever.
Oh, it's Queen Victoria.
Exactly. It's Queen Victoria.
What? She has it, actually?
Remember, she doesn't have it. She carries it. She carries it. Remember.
But that's kind of like she has it.
Not really.
No. It's kind of like you got it's kind of like you got affected in like something, but then it faded away. So you carry it, but you don't have it.
That's basically it. See, you don't suffer the symptoms. I think that's how you can think of it, right? If you remember, hemophilia is recessive. So if you carry the gene, you're not going to have hemophilia. If you cut yourself, you'll be fine. So this would be her genotype right here.
Wait, but what happens if one of those girls is X?
Could have been Queen Victoria's mother.
X. And by the way, what if it's X and HX, not healthy? Then what happens? Is there healthy every time?
Are you okay? Are you trying to draw this?
What's HH?
Yeah, that doesn't exist. This doesn't exist.
He's asking XHXH.
It
doesn't happen. It can't happen.
No.
I mean, what if it's not? I mean, okay. I mean, what if it's not healthy? It's just XX. What happens?
You're completely healthy, and you can't have children who have hemophilia either, right? Look at the British royal family over here. Look at the British royal family. Do any of them have hemophilia?
No.
No, because
right? None of their males have it. None of their females have it. And when they have children, none of their females have children that have it. So it's not likely that any of the females are carriers either. And come on, just draw on the screen. This one should be easy. This one should be easy for you guys. Number four. Come on. Draw on the screen.
Okay, what? So Leopold was Victoria's own. Okay, what must have genotype has been, bro?
Come on, I said this one was easy.
Is it this?
Right there.
What's this XH? Why is it XH?
H
I get it.
Hemophilia, yeah.
It's probably this then. Mom, Sean's bothering me. A lot.
Can you come up?
Oops.
So you guys all look like you got this perfect. So even if you haven't drawn it, I believe in you. I know you can do it. So number 5, none of the current royal families none of the royal families show hemophilia, but the Spanish one could still produce it. Why do you think that is true? quick note though, the German and the Russian family, they kind of, so.
Because the females didn't have it, but they could have carried it.
I don't get it. I didn't hear. Sean, can you go out? And can you move up a little? We have to see what's happening. And this is, I think that question's impossible.
Hey, you have the sheet too. Come on, you have it too. I sent it in the
most
chat.
likely has it. So then, could you scroll back up?
Oh yeah.
Beatrice most likely has it, and then this female usually has it, which means that since they have this many children, these two happen to have it, but this one got lucky. This girl possibly.
I think this guy has it, but then I think this guy has it.
These people do.
This guy got lucky, and then after you go down, this guy got it. This guy got it. This guy got it.
Those are all girls. They're all girls. Remember, circle means girls.
These girls all have it.
Yeah, so that means they could produce it because there's 4. Like,
Yeah, because if they like married.
Okay, guys, calm down.
50% that
Calm down.
Get a girl.
Calm down. Okay. First of all, we can't prove that any of these girls have hemophilia because as of now, at least, they don't have children. So we can't, and they haven't consented to a blood test or anything. So we can't prove that they have hemophilia. So even though they didn't have children and we can't prove that they don't have it, why is it still possible? You guys already half answered it, but I just want a clear,
it's because
answer.
They have so many girls that it's like basically almost impossible for them to not have. Wait, that doesn't make any sense.
I mean, like
this person isn't married to anyone,
right? None of these women currently have children, so it's impossible to tell that if
they
they have hemophilia or not.
But they could.
So the thing is that if they have like
I don't know what happened.
borrow against your crypto at 0%.
I have no idea what happened. I have no idea.
So it's because if these guys have children, it's 50-50%. They will have a boy, but if they do, they might also 50-50% have a girl. So if they have a girl, it just keeps going.
I mean, I suppose you could put it that way. Basically, the answer is they're all female. They don't have children. They don't have any children who have it. So it's possible, but we don't have any proof for that.
I mean, like, so first of all, England didn't get any, right?
Yeah, basically.
So how?
Well, they got lucky. That's the only way to say it, really. They got lucky.
No, wait, can you go up? I think I know why.
Come on, you have the chart.
Oh, yeah, I do. But anyway, it's because Queen Victoria's on that side. No, I mean this side, wherever you're looking. And then Albert's on that side. So, yeah. I mean this side. So, yeah, we got lucky because...
Who has a question?
Me.
Go ahead.
In the German royalty, they have 2 children that are like have hemophilia or whatever it's called.
Yeah.
Like, did they have any children or?
Nope.
Was it the only?
They don't have any children. We're just
none of them had children, so like the royal family is just gone from there, right?
Yeah, the German royal family is basically from there. And something I actually forgot to mention to you about the Russian royal family, who knows what happened to them?
No more king.
Right. So specifically, who knows what happened to the Russian royal family? None of these people, 4 girls and a guy, none of them had any children. Why do you think that is?
Because they all had a very high chance of having hemophilia.
They didn't care. None of the girls had hemophilia, and nobody back then, I don't think, understood how the hemophilia thing worked. So why do you think that none of them had children? Come on, it's the most obvious answer.
They just didn't want to.
They weren't old enough.
Why weren't they old enough? You eventually grow old. Why weren't they ever old enough?
Because their mother and their dad had children very late.
They died. They died. That's basic. So the whole Rasputin thing, it all happened in 1916, 1915, that kind of, in that era.
What is that? Like the sword thing?
That doesn't matter. Not for now. So okay, you guys should know, you should be learning in this school about sometime now. What do you guys remember happened in 1915 and 16?
War.
What's happening back then?
War.
The First World War, right? So specifically, how did Russia handle the First World War?
In what sense?
How was Russia doing in the war, in the First World War? How was it doing? Was it losing? How bad?
Well,
Pretty badly. I don't know any. I know a little about First World War, like probably 0.01 about it, but I know pretty much like the whole thing of World War II.
Fair enough. So the thing of, okay, most of you guys would probably be taught the Western Front mostly, because that's where Canada, US, that's where the West fought, because Western Front and all that. Russia in World War II was doing extremely badly. They had a massive army, a lot of people, but they literally went into war against machine guns with pitchforks. That's how badly they were equipped. And now this guy right here, this guy, Alexis's dad, Tsar Nicholas, because he is, he's a Russian king. He tries to lead the military, and pitchforks charging against machine guns. They lost very, very, very badly. So the Russian population at this point, they were getting sick of it. They were under the Russian kings for hundreds of years, and their living conditions were absolutely terrible. The rest of Europe was pretty prosperous in comparison, right? They all had proper cities, at least. People had running water. They had schools. They had factories. Russia back then was still like 80% farms, rural areas.
Wait, so does that mean this part is only agriculture and stuff like that?
Basically everything east of Moscow, most of it is just wasteland. It's just not even farmers live there. So people were getting sick and tired of the living conditions, so they revolted. Now, who knows who the revolutionaries eventually elected? 1917. Who did they elect? Who took power?
What's his name?
Not one.
Some guy.
Which party? Which party took power?
Communist Party.
And what do communists think of kings?
Bad. So they took over. Revolution.
Right. And then you've taken over the country. You've captured the king. You've captured the king, his wife, and all of his children. What do you do with them?
Kill them.
Kill them.
What happened. So the entire Russian royal family is just
Boom.
Yeah. So that's why we can't say if any of these 4 girls had hemophilia or not, because none of them ever grew old enough to have children.
I know, which is bad because I don't want to get killed.
Nobody likes to get killed, Lyndon. It's not fun. So let's give the 6th question a look. If there was, as we mentioned, right? What was the only royal family that didn't have hemophilia issues?
England.
England royal family?
Exactly. The English royal family. Yeah, y'all know Queen Elizabeth, right? It's still very strong. So you guys look at the sheet you currently have, right? You guys pull it out quickly. So if Alice's, who is, look at Alice, right? If Alice's daughter, Alex, accepted a proposal from George V,
Who's George V?
look at your chart. Who is George V?
I don't have it. Oh, then.
Come on. So
Oh, here I do. Now I do.
if Alex married George V, what's the probability that their offspring would have hemophilia?
Why would he even marry a George the Fifth? Because they're two different things, and they're approximately like 10 centimeters away.
10 centimeters away on the family tree, Lyndon. They were thousands of miles away in different countries at any given point. Okay, so let's say that Alex was to marry George V. What's the probability that their offspring would have hemophilia?
25% of the time.
Justify that answer.
Okay, if you look at the chart, the person that Alice marries.
Alex.
The person that Alice marries doesn't have hemophilia, but Alice most likely does. And then that means that Alex, we're going to assume that she has this genome. And all of the other ones.
Wait, what?
Some of them got lucky. But then George, who is on the clean side of the hemophilia, royal disease kind of thing, he's completely fine. So he has 0, right? Like he's completely clean. There's nothing wrong with him. But the girl has 50%. So the middle is 25%.
Yeah. That's basically it. Can you draw? Okay, Ethan has explained the answer. Lyndon, why don't you draw the Punnett square to prove it?
So,
Come on, Ethan. We know you can. I know you can do it.
So, well, so Queen Victoria probably gave Alex the hemophilia.
Yeah.
And then hemophilia.
Yes.
And then so XH doesn't work. Wait, what? Anyway, doesn't matter.
Doesn't matter. Weird. You just need H in there somewhere.
But XY will, I think. Yeah, it will. And then XX doesn't. What? And X with X, well, YX, it doesn't work either because this one doesn't have H. So this one doesn't. Nope. So yeah, it's 25%.
That's basically it. That's it right there. 25%. So look at the 7th one. What ended up happening again? Alex accepted a proposal from Tsar Nicholas. So looking at the Russian royalty, right? There were a bunch of children with issues. Alexis was especially evident, right? It was the one we're discussing. So none of the daughters, again, we covered, they were all killed by the communists. None of their daughters could have children. So knowing that, what do you think what's the possibility of one of their daughters carrying hemophilia? What probability? I'm wrong. Probability of one of the 4 daughters carrying hemophilia. So think about it, right? Alex, as we know, she's definitely a carrier because she gave birth to a child who has hemophilia. Again, I swear to God.
25% of the time.
Right. So we know Alex has the hemophilia. We know that Tsar Nicholas doesn't. So come on, I've basically done it for you. What's the percentage?
25%.
Are you sure it's 25? We're talking about the daughters.
Oh, there's 0.
The chances of one of the daughters carrying hemophilia. You've had your turn. You've had your turn.
One of them.
Come on.
One of them.
Why one of them?
Because like if one of the sons had it, then like another like daughter had it.
No, we're just gonna ignore the sons for now, right? We're just looking at the 4 daughters. Out of the 4 daughters, what's
Or 2 of them because 2 of them. 2 of them. Because like if you have like here, one of them has the thing. So and then if you make 4 people, then 2 of them will have it.
Okay, percentage.
Theoretically.
Percentage. What's the percentage?
50% of the time.
Pardon?
50% of the time.
50% of the time. So 8 again. Assuming that Alexis ended up having a child, what's the possibility that one of his sons would have hemophilia? Right? This time we're going to use a hypothetical that a male who has active hemophilia has a children with a female that has no issues at all. So what do you think the chances would be that Alexis has a male child with hemophilia, himself being a male who has hemophilia?
0.
Why do you think so?
Because if you use the Punnett square, none of them are male with this thing.
Let's see what Camille's drawing.
Too blurry. I can't
None of them.
see. Everything looks like 1.
Why don't I draw it then? Camille did it correctly. So Alexei, he has this genotype, right? Because whoa.
Oops.
All it takes is, because as we know with males, all it takes is 1 gene to have it because you don't have another gene to basically act as buffer. So we're assuming that that his wife has a normal one. So again, all of his daughters could carry it. All of his daughters could carry it, but none of his sons will actively have hemophilia. We all agree?
Yeah.
All right. So we basically answered question 9 already. Shout it out. Who is? I blanked this out on purpose to make it harder for you guys. Who is the first person?
Queen Victoria.
That's right. I'm not going to write that down because I can't write that small. Queen Victoria, within the English royal family, was the first person to have the allele for hemophilia. How do you think this allele could have appeared in Queen Victoria?
Parents or grandparents?
Specifically, which set of parents or grandparents?
The female one? Because if the male has it, it has to be black. It's common sense, right?
That's basically the answer. Because Queen Victoria's father didn't have hemophilia. It's only possible that she got it from her mother. And again, Why is inbreeding wrong? Because once you have that allele for hemophilia and you have children with your cousins, you're going to pass it down. So again, we've basically, why don't we, we've already done it basically with 8. Number 10, what do you think?
Zero.
No,
It's
because okay, I'll try it, I think.
wait, normal female is assuming they don't have the
So X.
Assuming that they don't have,
No, because they can have
it, right.
the girls. They can have it in the girls, but not the boys.
So
But no, my question is, we're assuming that the person that this male hemophilic person marries doesn't have a
0%. It's 0%.
Normal means they don't have hemophilia. That's all normal means. You don't have hemophilia. Nothing else.
0%.
Does it mean that they can carry it, but they don't?
Not going to tell you that.
The daughters can have it, but not the sons, because
I'm not going to tell you if he marries a carrier or not. I'm just saying he's going to marry a normal one. Is it possible that he has a son with hemophilia?
Yes.
Why is that so?
Because the reason I asked you the question was to justify this, but you said I won't answer that, so most likely it's yes.
Yeah.
So, yeah, XH, and then this child would have the H.
Yeah, that's basically it. You know, if you go off that assumption that if I say I refuse to answer, that I'm saying yes, you're set for life. Okay, so let's expand the question again. And Ethan, you're not allowed to answer. Let's assume that Leopold did marry a carrier. Is it possible to have a girl with hemophilia then in that case? Assuming that he did marry a carrier of the hemophilia gene, himself being hemophilic, would it be possible to have a hemophilic girl?
Yes.
Yes, and the percent and what's the chance of that happening?
50?
25%.
Yeah, that's right. Okay, we also got through this a bit quicker than I expected, so I'm just going to pull out the backup questions to try and mess you guys up. Let's see. Why is there so much? Okay. Wait, no, God. Okay, can you guys here? Why? No. New share. This is the old notes of why does it? Can you give me a second, please? So, where did I put those questions? Okay. Don't tell me I deleted. Okay, thank God. All right, so here. That's the stuff we just did. Now, I copied these questions off somewhere. First question here. Let the X-linked recessive traits of color blindness is present in 5% of males. That's just a statistic. It may or may not matter. So if the mother is a carrier, the father is unaffected. If they plan to have 2 children, what's the possibility that the children will be both male and colorblind? You know what? Go ahead, Ethan.
It would be 0.5 times 0.05. So that would be, let me just do the math.
Where does 0.05 come from?
5% of blindness.
Colorblind. 5% of color blindness is present in 5% of all males. Are you sure that's relevant to the rest of the question?
Right.
You've had your turn. Someone else.
It's no.
All right. Who else wants to give this a shot?
Wait,
Loretta,
what's the question?
The one down here. Loretta, you're usually pretty active. What do you think?
The X-linked recessive trait of color blindness is present in 5% of males.
Do you have any idea, Loretta?
No.
0%.
You guys can draw the Punnett square if you want.
Wait, actually, no, 25%. Wait, actually, no, never mind, 0%.
Remember, both male and colorblind.
No.
What's the chances that they're going to be both male and colorblind?
0%.
Both of them would be male and colorblind.
0.
Camille drew it out for us already, so thank you, Camille. Right? There's a 25. We all know that there's a 25% chance that they have one child that's both male and colorblind, but both 2 children. Remember, 2 children, male and colorblind. What's the chances of that happening?
Say it's theoretically 25%. Theoretically, if both children are like this, it'd be 0. But
it's 25%.
They could both be in this square.
Remember, it's 25% for one child.
So
what
they
about
roll
2 children? Okay, this is probability, so it might not be fair to test you guys on this. The way you do it basically is like this. As she drew out, it's a 25% chance that one child. It's a 25% chance that one of them has it. It's a
6.25% of the time.
Yeah, it's 25% of the time. So 25% times 25%. Now 25 is 0.25.
Equals 0.0625.
Yeah, that's it. That's literally it.
I don't get it. How could 25 turn into 0.25?
0.0625 actually. So I'll just draw it out here. Remember, it's a female carrier and an unaffected male. So here you have that affected, fine. So that is very, very ugly X. So what percentage of this? 25%, obviously, right? 0.25%. Okay, so this is math class now. So it's 0.25. Why did I write X? It's 0.25%, not percent. 0.25 is 25%. Do we know that? Yep, 0.5 is 25%. 0.25 is 25%. So we have 25% here. That's the chance of one child being both male and colorblind. But we want to have two children, right? So another 0.25. Multiply that together, we get 0.625. 0.0625. That's messy. 0.0625. Do you see how this works now, Lyndon? Because you're not having one child, you're having two children. So think about it as having two dices, right? What's the chance that you throw a 6 twice, right? You throw one dice, that's 1 out of 6. But you throw two dice in order for them to both be 6s. It's 1 over 6 times 1 over 6, which is 1 over 36. Same thing in this. It's basically 1 over 4 times 1 over 4. So let's scroll down a little. Why did I do the same question twice? I'm a genius. Corn. This should be more familiar to you guys. One for yellow kernels, one for white kernels. You mix them, you get 2 ears of corn with approximately even yellow and white kernels. What's the relationship between the two alleles? Not you, Ethan. Lyndon, if you're saying anything, you're muted.
I know I am, but can you scroll down a little?
It's right over here.
Oh, can you make it larger?
I suppose I can. Give me a second.
Hey, but aren't you showing?
Codominant?
Codominance, that's right. It's just codominance. What have I done?
I think you gotta small it down.
Yeah, I think so too. So, okay, we're running out of time, so I'll give you one last little question here. This one over here. In Labrador retrievers, the allele for a black coat is dominant for the allele over a brown coat. However, if a Labrador has two copies of a recessive gene for another pigment, has two copies of a recessive allele for a pigment depositing gene, it can only have a yellow coat. And remember, we've only been doing this with one allele, but with one set of genes. But of course, you have millions, if not billions, or maybe trillions of genes. So let's assume that let's use the gene for black. Remember, in this case, black is dominant over to brown, and for this pigment gene, you normally have a normal pigment deposited, but you can also have this defect that makes you have a yellow fur. So if you have two dogs with this genotype, what's the chance that the next generation will be yellow?
So it's the E that makes, like the small E that makes you yellow, right?
We do this. I don't know.
Remember, big B is black, little b is brown, big E means normal, small e means yellow. Go on.
So then it's B here. B. I think he's muting you because I don't know, you talk too much. Same as me. So this is because you're too smart.
You know, you can just go to like your system like thing and they can talk there and then you can't mute you.
Here, think about it this way. Are you guys sure that B matters?
Doesn't really. I know, Ethan, you're too
smart.
smart. I think it's this. Oh yeah, wait, no.
Ethan, you can talk now. It's fine. I'll let you talk now.
The colors don't really matter.
Which set of colors does not matter?
The brown and whatever that was, like the brown and the black.
Yeah.
Don't matter. So you're just talking about E, big E, small e. So
Right.
25% of the time.
Yep, that's right. I think I've
I get it. Hey, didn't we do this on the first class?
basic. I don't think I did this on the first class. I think I'm only doing it now just to confuse you guys because I'm mean and evil. Okay, I think that's enough for today. I guess I'll see you next week then.
Bye.
Thank you. Bye.
Thanks, bye.